Hello everyone. I'm Kanishk
I'm Srinivasa.
and we both work as founding engineers at SendAI. At SendAI, we are building infra for AI agents, workflows, and MCPs in general. Today, we will be talking more about AI agents and crypto, specifically towards workflow and wallet infrastructure, which make the AI agents and workflow safe and reliable.
So we are the tooling and economic layer for AI agents. Our core thesis is that every AI agent will have a wallet. When it's compared to Web2 infrastructure, so there are a lot of gatekeeping and there are a lot of guardrails and there is a lot of limits for any transaction or any kind of financial action to be happen. Let's say if you're doing a simple UPI, it will take a lot of time to just open the app, execute it, and there's a specific limit for a day, etc. But uh, the best part about crypto is that it's very programmable, and crypto is like programmable money, and that link to an AI agent is like a perfect combo. And our thesis is that AI agent will trade for you, gamble for you, they'll browse, invest, manage your portfolio, and pay for anything you do on chain. And here's an example of a sample agent which would be possible in the coming future. Is that let's say there's a Meteora agent which finds you a trending token which has a lot of volume, and it will create a liquidity position, and it will manage your liquidity position and earn all your fees. And what we have built till now is majorly the one of the hit product is the Solana agent kit. I think most of you might have known that. It has 50 plus protocols integrated, 800 plus folks, 1.6k plus stars, 82 plus contributors, and more than 130,000 npm downloads. So we have heard from devs that it is more easier to integrate the agent kit rather than integrating the actual protocol itself. And powered by the Solana agent kit, we have our own remote MCP server where you can plug in your remote MCP server to Claude or ChatGPT or any of the chat interfaces, and you can take financial actions real time just by prompting. And we have also built a Raycast plugin. I think most of the devs here might have used Raycast. Think of you just having to click two buttons and you could have executed a trade. So you can also perform multiple complex actions like limit order, DCA, etc. Everything from Raycast.
That's the foundation that we have built so far. But quickly we realize that the real problem is not just calling the APIs, but the real problem is that we need AI agents which are reliable, durable, and are safe. And that makes them production ready. So you can think of AI systems as distributed systems on steroids. So AI system will involve that when you run an agent, you are just not running a script. For example, if you are running a workflow and you are just coding it, you are not just writing a script, but it's all orchestrated and distributed workflow. Think of it as a Kubernetes pod. So it is managing multiple services in parallel, running coordinations, and for example, some tasks return you the output instantly while others take minutes. Then all of these tasks come together and form a DAG, which is a directed acrylic graph. Then everything is so unpredictable that if first step fails, you need that it retries. So everything, all that needs to be happen securely and reliably. So for that we need workflow. So users will need workflows that are long running. So they can create workflows which can run for hours, days, and months, and they are crash proof, have retry logics built in, and they are persistent. Multiple services can talk to each other, and like they have human in the loop for policy based pauses. All this workflows can be asynchronous or synchronous, have synchronous executions. Like in workflows, there will be multiple agents, and some agents might need to wait for the previous agent to finish its execution, while some parts will just continue synchronously and execute parallelly, right? So we are building all the infra to support all of these things, so that a normal consumer don't have to write code and build their own bots. Everyone can come and on our platform and using natural language can build all of this, and we take care of everything. So what? And all of this can't be non-deterministic. No user will give its money to the AI agent and will be like, "Okay, I'll see whatever happens with it." You consumers will need some kind of a deterministic output. They should know what will happen with its funds. They will only trust the system which is fault tolerant, which have retry logics, which is reliable, and they know as a consumer that what exactly is going to happen with their funds. So for this, to build all of this, every AI agent needs to have a wallet. And how we are building this is, our core thesis is that agent must be able to do transactions on your behalf, but LLMs are probabilistic. They hallucinate. You can't just hand them over your private keys. That would be very foolish. You need a wallet infrastructure which manages all that for you. You will hand over your private key to the agent. So for that, we need wallets which have guardrails implemented. They have sandbox execution environment. So what we are doing is, we are every agent in our case have its own wallet, and it have access to its own funds, and it can't interact with the funds in your main wallet. So every agent have its own wallet and access to its own fund only. We have policy engines which we are designing, which is, you can think of like firewall for money, firewall for your money, which have daily spend limits, whitelisted programs to which your agent can interact with, so that you don't lose your money and everything is safe. And you can have programmable authorization logics, like let's say if user wants that below $100, he wants to give the wallet agent autonomy that it can do anything, but above $100, he want to receive a notification on his phone that any transaction above $100, when he approves, then only it should execute. That can be built. And then there is a determinism. Every wallet action is reproducible and explainable. This is our multi-layer wallet architecture which we are building. It's not just a key pair, but you can think it of as a controlled execution environment which is like two-factor authentication for your agents, which balances autonomy with safety.
And the next big problem is prompt and context engineering. All of you might have used Cursor and ChatGPT. Like ChatGPT keeps getting better with context. Similarly, Cursor, if you give specific files to edit, and it will get context from those specific files, and it will edit. Think of it something like, if you are giving an agent just the coordinates and ask it to, for example, I have to go to Taj. So I'll give it just the coordinates and ask it to help me as a travel assistant. That will hallucinate. For that, what we need is like, similarly, what we need is for Solana, like we need on-chain context, and Solana's millisecond latency is very crucial for if we are building workflow kind of a product, or a real-time product which should need access to real-time prices. So, for example, so for this, the solution is that the MCPs. So from MCPs, we'll do dynamic tool calling. The LLM will have access to certain tools. Let's say, for example, if you want to fetch price of send, then we'll have a tool to fetch price. That tool will have access to the data which is real time, and that data can be returned to this agent, and agent will obviously be real time accessible to all the real time data. For this to happen, we need these three things to be optimized a lot. One is the KV cache optimization, where we'll need to store specific data points from the chat history or users behavior, and we'll also need to make sure that this is within the context window, and we'll need to have 2 to 3 LLMs orchestrating. So let's say if there's a action, like you have to buy some tokens. Let's say you have the agent to buy some tokens. After it buying, there should be another agent which will verify if the tokens have been bought or not, and if the transaction has been landed or not. So we'll need multiple agents, not a single agent. Even for a simple action, we'll need multiple agents that will orchestrate together very autonomously. And another big problem is the reading Solana. Solana is a gold mine of data, and every data can be accessible on chain. Unlike Web2, where data is the only mode. However, it's very unstructured, and this is actually should be like an advantage, because you can structure that data according to your needs. So whatever the LLM needs, or whatever the structure the LLM needs, we can have our own indexer. So we are actually working on our own indexer, which will index all the Solana data that is needed according to what the workflows that would be built on top of the infrastructure. And we'll also be we are also will be starting our own validator for all this to be very optimized.
One more big problem which AI as an industry is solving is memory. Without memory, agents are stateless. Like, imagine a trader who doesn't know anything about his past trades, which will be very useless. So for that, we are solving it by having two layers of memory. One is short-term memory and long-term memory. So short-term memory, agent will have context of what happened in the past transactions and past its workflow. While in long-term memory, it will be stored in database, and agent will learn from your past strategies and will be able to create new and better strategies for you. And like, as we are stitching these short-term memory and long-term memory together to transform agents from stateless scripts into long-lived financial co-pilots that can actually get better over time and perform actions for you. And how would you, coming to evals, how would you trust an agent? So for that, we need evals. Evals is nothing but just fancy unit testing for the AI agents. Think of it like agent which constantly help us to make our systems better. So we have on-chain evals and off-chain evals. In on-chain evals, we are running simulations on testnet, verifying transactions. While in off-chain evals, we are benchmarking workflows and having reasoning checks. Over time, this becomes the foundation for trust and reputation of the system. Because in agentic finance, you won't trust the code, but you will trust the reputation of the agent and its track record. You think this as how you will trust an NPM package by its downloads and its test coverage. Similarly, agents will be trusted based on the evals and their on-chain reputation. So that's some of the hard problems we are solving at SendAI. There's more to it, and if you are interested in the intersection of crypto and AI, and are interested in the problems which we are solving, you can come and talk to us after this talk. We are also hiring across engineering and design divisions. So if you are looking for jobs, you can connect with us. You can also follow us on Twitter and me and Srinivas.
Thank you.
Thank you everyone.